Welcome back. So today we're going to look at the derivative of a trig function, specifically sine x. So we're going to have three styles of problems that I'll work through, and there is just two main formulae that we're going to be using, and that would be the derivative of sine x becomes cos x. Okay, that is in the formula booklet if you're doing IB, otherwise you'll need to remember it. But I want you to think of it more explicitly as sine as a function of x. When differentiated becomes cos of that function, so the function here won't change, just this will become cos times by the derivative of this f of x. Okay, so I've got three problems that I'm going to work through. Like I said, all slightly different, and we're going to get started. Okay, question one. We have sine 3x minus 1, and it simply asks us to find the derivative of y with respect to x. So in these problems, we're just going to go straight in with dy by dx is equal to, now we've remembered that the derivative of sine is cos, so I'm going to simply just put cos, that's cosine. This remains unchanged inside here, 3x minus 1. But then what we must do is times by the derivative of what's in the bracket. So the derivative of what's in the bracket would just be 3. Okay, our final answer being 3 cos 3x minus 1. Finished. Question 2. The derivative of sine 4x squared. Now, I want you to pay close attention to this squared. This is just the x value squared. It is not the full function squared. Okay, so even if there is no brackets and you just see this, okay, the squared is associated with the x and not squaring the entire trig function. That we'll see in question 3. Okay, so what we've got now then is the derivative with respect to x of sine 4x squared will simply be, well, sine turns into cos, so differential of sine becomes cos, so it'd be cos. The function inside remains exactly the same, so 4x squared, times by the derivative of this function. Now, the derivative of that function would be 8x. So it's good practice usually to write that at the front, and that is the end of the question. Question 3. Let sine squared 5e to the x find y prime of 0. So they're asking us to differentiate y and then substitute a value 0 into that. Okay, I just want you to have a look at this thing here. Whenever you see a sine squared, what it actually is, it's the sine has all been squared, but it is just a notation that we use in trigonometry that when we square it, we put the square straight after the sine, but it's really saying that the whole thing is squared. That's useful because we can basically use chain rule here. So we're going to times by the power, take one off the power, and then times by the derivative of the bracket. Now just watch very carefully how we do this then, because there's going to be a couple of steps that we didn't do in the previous two examples, right? Okay, so y prime is equal to, now we're going to times by the power. Remember what I showed you here, we're going to times by the power and we're going to take one off that power. So it's going to be 2, and then we're going to leave this expression inside exactly the same. That was because when we did chain rule, remember when we had brackets, we multiplied by the power, took one off that power, but that thing inside the brackets stayed exactly the same. Now we need to multiply by the derivative of the bracket here. So the derivative of the bracket would actually be cos 5e to the x. Okay, because when we were just differentiating way back here, when we just differentiated sine, okay, it just became cos. Okay, but the function inside that bracket stayed exactly the same. So we just need to do that here. So that becomes cos 5e to the x. But then we also need to multiply by the derivative of the actual bracket itself. So the derivative of 5e to the x is actually just 5e to the x. If you watch one of my other videos on differentiating exponentials in this calculus unit, you'll see why, because the derivative of e to the x is still e to the x. Okay, so we have this big expression. We can multiply the 2 and the 5 together, giving us 10. Then we have e to the x, and then we simply have sine 5e to the x. I'll just put a bracket around that so you can see it a bit clearer. And then cos 5e to the x. Now it asks us in the question to substitute a value into this. and I believe the value was 0. Yes, here. Okay, so we're going to plug 0 in. Okay, so we've got 10 times, now e to the 0, anything to the power 0 is just 1. Sine e to the 0 is 1 again, so that'd be sine 5 times cos, and exactly the same happens over here. That would just become 5. And so that's our answer. So we have 10 sine 5 times cos 5. But this is a numerical value without a calculator. I'm not entirely sure what sine 5 is or cos 5. This is also actually a double angle. So I'm just going to leave that question there for you to post in the comments below. How could we tidy that up further using double angles? Thank you for watching. Don't forget to like and subscribe to the channel to see more math tutorials. Check out my playlists on my channel or click one of the videos above. I'll see you next time.